Hi there. So this point in the job now, we're in the final stretch. We want to take a look at flipping over the part and scrubbing off the last of the material on the bottom, because if you remember when we first defined it, we defined 2 millimeters extra on the top and the bottom of the piece that we're working with. So in order to do this, we need to start looking at something called setup stages. Now, this allows us to define various different orientations of the workpiece without losing any of the core positional data we need for datuming it. So, to define the first setup stage, which is what we've already got thus far, we need to tell it that that is a discrete stage at this point, and that is something it has to retain. And it'll inherit the values for this particular setup from the initial setup values that we gave it right at the very beginning. Now, in order for this to work, we need to make sure that no prior setup stages have been defined. And to add a setup stage, we go to Add Operation and Structure and Setup Stage. And you can see how automatically it's nested everything that we've done so far inside that first setup stage, which is pretty much ideal for what we need. So it's also automatically inherited this positional data as well for it, which is perfect. It means we don't have to redefine anything. However, now we are going to want to add a new setup stage after this list of tasks. So we're going to go back to the bottom of the list. We are going to go to Structure and Setup Stage, and we're going to define a second setup stage now. One thing that you may have noticed is that I inadvertently reset the engraving path. So I'm going to very quickly regenerate all of the toolpaths in setup stage 1. And you see that's gone through very quickly, and now setup stage 1 is occupied as having full content of toolpaths. However, what we're looking at doing now is we want to flip over the part. So we go to setup stage 2 and we stay in the setup inspector tab here. And we want to change the workpiece setup. So we're going to double click on this and it'll open up this window as well as giving us these controls to take a look at. And we want to flip this over in this direction. So I'm going to go to the front view and I'm going to zoom in and I'm going to drag this arrow around so we can see that the rotational value in Y is now going to be 180 degrees, but we also need to change the value in Z so that there's enough material here for the vise to grip on, because don't forget this is not a flat surface and nor is this. So I'm going to drag this down using these controls because I don't know the fixed numerical values we need at the moment, and I am going to lock that there at Z83. It's not a perfect round number, but it seems like a good height for this. So I'm going to click on OK now, and we're going to pull back out to take a look, and we can see that the piece has been flipped over accordingly, exactly as we need it to be. So we can now start taking a look at adding the final operations for this. And the two things that we need to do is we want to round off these corners around the piece, and we want to face mill the back of this down to the final thickness. So let's take a look at rounding off the corners first. I am intending to add a 2D contouring operation to do this, so we'll do so here. However, we don't have specific curves defined for just the corners. We've only got the ability to go all the way around, and we don't really want to track the edge all the way around because that'll cause problems with hitting the vise. So to resolve this, we're going to go back into the model space and we're going to very quickly whip up a set of arcs that we need to achieve this. So we'll click on Model and we'll set the view to bottom, and we will click on parts.igs because that's what we want, what's going to happen next to be predicated on. And I'm going to generate a new sketch. So what we want to do is we want to use each of these center points that we defined previously for our hole machining paths as a center for an arc that's going to cover a 90-degree section there. So we're going to go to the arc tool and we're going to go with arc with center, first point and angle. So we click on this, and with Smart Snap turned on, we make sure that we snap onto the center point here, to the top, and then bring it round to the 90-degree point. And we're going to do the same for each of these. So we have a nice 90-degree arc defined exactly as we need it to be able to clean off the last bit of the exterior of the material there. Okay. Now don't forget to turn off the arc tool afterwards, otherwise you'll find yourself inadvertently drawing arcs all over the place as you click around the screen. So now we can go back to the machining environment and we can move back around so things are a bit more visible. I'm going to turn off machine visibility for the moment just to make our life a little easier for this, because we now need to select each of these arcs to define the next toolpath. So I'm going to go into job assignment and I'm going to grab 1, 2, 3 and 4 and then click on curve. So that's now set our arcs, and you'll notice it automatically goes right down to the 0 point of the job, which is not really something we need it to do. So we're going to set a bottom level on this as well, and the easiest way to do this is to select the face where you want the job to stop. So I'm going to click on this face and I'm going to click on bottom level. Finally, what we need to do, we need to define the lead in, and we need to define the tool that we're going to be using, because at the moment this has still got the 10mm engraver selected. So we're going to go to tool, we are going to change the tool to the 20mm cutter that we were using before, and I'm going to select the tool for the operation. There is one thing that we've missed as well. Can you spot it? And just in case you can't, we need to set compensation on each of these. So I'm going to turn on compensation now, and we can see how it's automatically defaulted to compensation on the wrong side of the arc as far as we're concerned. So I'm going to flip that round by clicking on this icon here, which is the machining side and inverse curve icon. And if I click on each of these, we now have it going around the outer edge, which is where we need it to be. So finally, we're going to go to links, and on engage and retract, we're going to define by arc. And you can see how we've now got that nice lead in and lead out on each of those cutting arcs. Okay, so we can now generate the toolpath of this. And in doing so, we now have a lovely clean definition, cutting in, cutting out, and making the perfect arc that we need. So I'm going to turn the machine visibility back on for the moment, since we now no longer need to worry about visibility on that. And we're going to very quickly simulate this just to make sure that we're happy about it. So I'm going to click on simulation, and I'm going to click on first I'm going to click on simulate up to current operation, because we can see the workpiece has been reset. Okay, and then I'm going to click on run. And once that comes down and starts cutting, we should hopefully see a pretty positive result. So we've got a good lead in there, and it's taking off the edge of the material exactly as we intended, and a nice lead out. So it's safe to say it's going to repeat that pretty cleanly 4 times now. And there we go, we've managed to cut our outer edges without having to use the entire exterior contour of the part. Very quickly, very easily define those parts. And of course, the last machining operation that we want to define is we would like to face mill this. So I'm just going to snap back around to the cleaner view, and we want to face all of this off. So we're going to go to add operation, 3D entry, face milling, and we are going to check the setup just to make sure it's got the top and bottom levels right. You'll notice it says 24 and 22 instead of 0 down to -2. That's because it retains the depth values from the original setup, which is what I meant when it said it inherited those values from the first setup when we were implementing the setup stages. That 2mm is exactly the correct value that we need, so that's all good. We've got the correct kind of tool. Everything else about this we know to be good. It's the spiral with a 15mm step over. It's exactly the same as we had our first setup be. So I'm going to click on generate toolpath now, and we can see that's exactly the kind of toolpath we'd expect. We're going to simulate it very quickly just to make doubly sure. and there are no surprises here at all, which is something that I always like to hear, especially when setting up a machining job. Surprises are not your friend. So, now that we've got all that, and we've run through our iterated simulations, there are two final tasks that I'd like to undertake. The first of which is post-processing. So we want to generate the final output file that we can load onto our machine. And then we want to take a look at G-code based simulations just so we can verify everything that goes on in the produced G-code. So, firstly, I am going to make sure that everything has been calculated. So we just quickly regenerate all of the toolpaths just to be certain. And then I'm going to click on the post-processor button here. And you can see I've automatically got the FANUC 30i mill controller post-processor defined here. If at any point you need to find your post-processors, you can click on include using the file explorer. Note it will generally give you the list of folders and you select a folder instead of an individual post-processor, just as a general point of reference. So I've got this defined and I've got the file name defined as well as where I'm intending it to save. So I'm going to click on run now and we'll give it a minute to work it out, and we can see we've now got this lovely FANUC style G-code file defined. Okay, so now that we've done this, we can exit out of here, or we can show it in the folder just to check. So there you go. That's our latest version of this. This was a test run I did a little bit earlier on. I'm going to exit out of that. I'm going to exit out of this screen. We're going to go back to simulation and we're going to turn on G-code based simulation. Now this does take a few seconds to process. Okay, so don't be alarmed if there's a slight delay. I'm going to pause the video whilst it's iterating through this so as not to waste your time. So click on that. We will need to choose an interpreter. So you'll get this window come up and you'll need to double click on interpreters, common, which is the folder I just clicked on. We're going to go to mill and I want to use the FANUC 30i mill interpreter since that's the G-code post processor that I've already used. And I'm going to click select. I'll catch you in a second once this is done. Okay, so that's now finished generating. And obviously you won't see much of a change right now, but we're about to get into it. So I'm going to expand these setup stages so we can take a look. And I'm going to click on the first operation. And you can see now we've got the G-code for this whole operation generated. So we can have a quick scroll through here, make sure that everything is as we expect it to be. But also we can examine it whilst we're running the file. So I'm going to click on run for this. Okay, so as you can see, as it iterates through, it opens up the relevant G-code file for you to be able to check out what's going on. I'm going to speed up through this a little bit because obviously there's a fair bit of machining for it to do, but I'm going to hang fire for a second. I just want to make sure that all of the initial stages are good. And so far everything's looking positive. So yeah, we'll let that speed up a little bit. Obviously we don't want to watch the whole simulation if we can avoid it, but it's always worth giving the thing a final check through. Okay. And so far that's looking good to me. It's coming up with everything we need it to. I'd say that we're probably doing okay at this point. And it's automatically cycled through flipping it over. And there we go. We have our complete job totally simulated with G-code verification that we can step through to look at each and every one of the stages if we need to. We can see if there's any manual adjustments that need making to the G-code or if there's something wrong with the generation of it. In this case, there isn't. So hopefully this project has been helpful and illustrative for you. Obviously, we're here to help, so if there's any further questions about how these things work, please do email us. And I will see you in the next video series. Thank you, and take care.